Alright, so now we continue with from the previous video. So in the previous video, we already discussed how to use the iteration formula to locate to get the approximate root. Alright, so I also demonstrate by using a calculator apps to show you how you press the formula and how you go through the whole process. So from this video onwards, please make sure that you try to use your own calculator and then try to press it out and see whether you understand it or not. Okay, so for example 6, so for this video, we're going to continue from where we stopped in the last video. So we will start with example 6 here. Okay, so if you look at this question, they give you the integration equation. All right, so first of all, they want you to show that A satisfies the equation of this. All right, so to get the A, generally you need to do the integration, right? Okay, so this involves some knowledge from the previous chapters, which is integration. So you need to revise the integration knowledge again, and then you can only continue with this. All right, so I will discuss this question with you here. But of course, the details you need to still refer back to the integration chapter before, right? Okay, so now I want to prove that A satisfies this equation. So to get the A, what I need to do now is I need to actually integrate this and let it equals to 6. Then from here only I try to get the equation for the A. All right, so I will start now. Okay, so if you look at this equation, they want you to do the integration. All right, so if you look at this one, generally, what kind of method you should use, the integration method, you have to decide on your own. All right, so what is the integration method that is can be used for this equation? So from here, you can see that this equation consists of two different functions. The one is algebra, another one is logarithmic function, exponential function. Right, I hope that you can see it. All right, so this one, algebra is A, and exponential function is E. And then we are actually follow the leg rule, right? Okay, that means when you go further down, what is the substitution that you need to do? So that means when you go further down, it should be dv. Then furthermore up, it is u. All right. Okay, so very obvious here, your u will be x. The algebraic function, right? So the u will be x. dv will be exponential power half x. Okay, so we will start from here. All right. So since I already decide my u and x, my u and dv already, then I will start. So I will let u equals to x, and I will let dv equals to e half x dx. So for this part itself, I want to do the differentiation, and for this part, I want to do integration. All right, so I put the integration sign here. So differentiate du dx, I will u equals to x, I'll get du dx equals to 1. Then for this part, I'll get v on the left hand side. Integrate e power half x. I should have e power half x divided by the differentiation of the power, which is the half. And I will get 2e power half x. All right, so once I done this part, then I will continue with the steps. So the integration by part formula is uv. So what is your u here? Your u is the x. What is your v? V is 2e half x. Then square bracket, and then a and 0. Minus, okay, so uv minus v du. So v is 2e half x, du is dx. And you let it equals to 6, and you still continue with the same limit. All right, but of course, all the details here, all the formula here, they are related to integration by part. So I think if let's say you're not so sure what am I doing here, it will be better if you go back and refer again the integration by part formula and everything and the whole process. All right. Okay. So for me, I'm not going to waste time to explain more here. I will just continue with the steps. All right. Okay. So for this part, if I want to substitute the limit a into the equation, what do I have here is 2a e power half a. Okay, then substitute 0 into the x, I will have everything equals to 0. So I'm not going to write it out. Okay, then I come to this part. I will take out negative 2 because it is a constant before I do the integration. And I want to do the integration now. Okay, integrate e power half x, I have e power half x divided by half. So you can see that all this integration technique, in case you already forget again, go back and do some simple revision again or refer to the previous video again. All right, and then I'm having a here and 0, it is equals to 6. All right, then continue further. Okay, I'm having 4 here, 2 divided by half, you'll get 4. And then only I start to substitute in my a. So substitute a into it, you will have e power half a. Okay, substitute 0 into it, you have 1. And then it is equals to 6. All right. Okay, then continue from here. I try to simplify everything. Okay. And then you just what you need to do now is you just try to simplify everything that you can. Okay, so as an example here, you can see that 2a e power half a, and this one, what can you do is that you just keep it first, or you can factorize out the e power half a. Maybe before we continue, we can refer back again. What is the equation that they want us to prove? So they want us to prove that x is equal to 2 plus e power negative half a. Okay, 2 plus e negative half a. So maybe refer back to the steps here. You can try to link and see what can we do. Okay, so I'm having 2a e half a, then minus 4 e half a equals to 2. Maybe I group all the numbers together first. Okay, and then after that, what can I do with this one? I can try to simplify the constant, and it will become so from here you need to think slowly. How can you get the equation that you want in the question itself slowly? Okay, then this is what I have. And then because they want to make the A as the object, right? So I maybe will keep this on the left. Then I think from here, I can see the answer already, because if I bring the E power half A over, it will become divided. And then for this one, this is what you get. And then when you try to simplify it, you have the answer. So if I rephrase it again, this is what we get. Which means A fulfill this equation, and therefore the A satisfy the equation x equals to 2 plus e negative half x. Okay, So because A satisfies this equation, right? So you just change it, become the X now. So A is a value, but X is a unknown or variable. All right, so you write out the equation in the variable form. So X equals to 2 plus E negative half X. All right, so this whole process, you can see that it's quite long. It is a complete integration question. All right, and then this integration question is actually try to lead you, okay, to get the iteration formula. I don't know whether you can see the style or not, but this is the iteration formula from the integration equation. Okay, but the whole process, you need to prove it out. You need to get the iteration formula by using the integration process. All right. Okay, then now let's continue to part number 2. Okay, so for part number 2, what do we have here? Okay, so they want you, by sketching a suitable pair of graphs, show that this equation has only one root. Okay, so now we come back to the very first method that we learned before. They actually want you to locate the approximate root by using the graph method. So again, a pair of graphs. So what are the equations that you should sketch? Okay, what are the graphs that you should sketch, right? So to save the space, I will just erase all the steps here. Okay, so you already know that from part number 1, this is what we get. So we get actually x equals to 2 plus e power negative half x. Okay, then now for part number 2, they want you to sketch the graph. Alright, so to sketch a graph, generally I think you should know already. Okay, so you have left hand side, you need to sketch one graph, which is y equals to x, and then the other graph should be y equals to 2 plus e negative half x. Okay? Alright, so the graph y equals to x is very easy to sketch. Okay, so this is the graph y equals to x. Okay, and then if you want to sketch y equals to 2 plus e power negative half x, so how can we do that? Okay, so first of all, you should know how to sketch e power x first. Okay, so e power x, the basic graph will be something like this. If you already forget, you should refer back to chapter 2. All right, I think we touched on the graph before for the exponential function, just like we seldom use it. Okay, so you must know that it passed through 1 here. Okay, after that you're having e negative half x. So when you're having this, it means the graph, the shape of the graph is still the same one actually, just that it become not so stepped. So that means it will become something like this. Okay, so this is still a 1. The 1 didn't change. And then you plus 2. So when you plus 2, which means that you have to move everything up for 2 units. So this 1 will move up, become 3. And then this asymptote, which is the x-axis, okay, because it will not touch the x-axis. So this asymptote, you have to move up 2 units also. End up, your graph will look something like this. Okay, so this is the value y equals to 2. And then your graph will look something like this. Getting very close to the asymptote, but it will not touch the asymptote. And then this is a value 3. Okay, so for the green color graph, it is y equals to 2 plus e negative half x. Okay, so from here, what can you observe is what they want you to prove. They want you to prove that there's only one root. So you are looking for the intersection point. Okay, so you can see that one intersection point. All right, so therefore there's only one root now. All right, so this is how we do the part number 2. Okay, so let's continue to part number 3. Verify by calculation that this root lies between 2 and 2.5. Okay, so again, this is very easy because it is a sign change method. So first step, you need to move all the function to one side, all the expression to one side. So you're having 2 plus e negative half x, then minus the x. Okay, all right. Then after that, you try to substitute the value of 2, and also you substitute the value of 2.5. Okay, so if I didn't do any careless mistake, then this is 0.368, and this is negative 0.213. Okay, so very obvious that you can see the sign change. One value is positive, another value is negative. Therefore, you make the conclusion yourself here. I'm not going to make the conclusion for you. Okay, and if we continue further to part number 4, okay, for this part number 4, they want you to use the iterative formula based on the equation number 1 to calculate the value of A. Correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Okay, so now, so your x1, they didn't give you the initial value also, right? So for your x1, you can choose whatever value that you like. Okay, so for me, I will just choose, okay, just now I'm having 2 and 2.5, right? I will get the value maybe 2.4. Okay, and then maybe this is the first value that I use. If you want to try on your own, you can use the value 2, you can use the value 2.5, and then to see whether we're able to get the same answer or not. Okay, and then what's the iteration formula? Again, just to remind you all, the iteration formula is this one. So when you key in the formula into your calculator, you should only key in the right-hand side. Okay, then you follow the steps that I showed you in the previous video. Okay, so according to my answer here, all right, so I'm getting 2.3012 as the second value. The third value is 2.3164. And then when I continue further, I will get the answer like 2.3144. So maybe this is x5. I skipped some steps already here. So I'm getting 2.3144. Then I will stop. Because if I double check with my answer, right? Okay, if I double check my answer in 2 decimal places, I think the previous answer gave me 2.31. This answer also give me 2.31. That's why I stop here. And after that, I will just try to make a conclusion. So what's the root eventually? So the root is 2.31. Okay, so no matter what value are you using, as long as your value is in the range 2 and between 2 and 2.5, generally there's no problem for you to get the answer, 2.31. Okay, and then again, for the first iteration, the second iteration, sorry, this one should be first iteration. If you want it to be on the safe side, then you write out the formula once. Okay, then half, and then 2.4, and then you get 2.3012. You just write out the steps, the formula first. Alright, so I hope that there's no problem for this example. So this is a complete example that involves all the methods. So you can see that they ask you to do the graph, they ask you to do the sign change, and finally they ask you to do the iteration formula. Okay? So if you have any question about all the small parts here, like integration and everything, then you have to spend some time to go back and do some simple revision on all the previous chapters. Alright? Okay, so let's proceed further for another example for this video. So for examples 5 and 6, right, so far, you can see that we actually can get the answer very easily. you can get the answer, the convergent answer, that means the approximation root, right or not? All right. So let us try one example that will not give you, okay, will not give you the approximate root one. Okay. All right. So here they say there are this equation, and then you have roots alpha and beta. Alpha is the value close to 0.3 and beta is the value close to 0. So they want to use this iteration formula. They want to find the roots by using these two different initial values. Alright, so again, now your iteration formula is x equals to e power x plus 1 minus 3. Okay, so key in this formula into your calculator and try to write out the iterations here. So when you key in negative 3, you will get negative 2.8647. Then if you continue, negative 2.8451. Then you continue again, you should have negative 2.8420. Then x5, I will get negative 2.8415. Okay, so from this part, I think I can stop here because very obvious, I can get the two decimal place number, which is 2.84. Okay, although in this question they didn't mention us, so I think I will just stop here because if you continue further, the value will be more or less at the value of negative 2.84. Alright, so I can tell you that, okay, I can roughly tell you if I want to stop here, then I will just tell you that the root is equals to negative 2.84. Okay, alright, then how about for x1 equals to 0? So if you use this initial value, but you are using the same iteration formula. So for this one, you have negative 0.2817. And then after that, you have negative 0.9491. Then what else will you have? You have negative 1.9478. Then what is the x5? For the x5, you'll get negative 2.6124. And after that, if you continue further, you'll see that the value will become more and more negative. It will not converge or lead you to one value. Alright, so for this one, you will see that we can't get the root. Or maybe if you continue further, but I think it's very many iterations already, your root is still negative 2.84. If you continue a lot of iteration for this example. Okay. Alright, so this kind of question will not be asked in the exam generally, but it is just for us to do some discussion. Okay, so from here you see when the root one value is close to negative 3. So when you use the initial value, which is equal to negative 3, then you will see that, okay, the root that you get is negative 2.84. Alright, so negative 2.84, which is quite true because the negative 2.84 is close to negative 0.3. And then they tell you that another root, the initial value is equals to 0. Okay, and then when you use the initial value equals to 0, end up you actually didn't get, alright, you didn't get the root which is close to 0, but indeed you get the root which is near to negative 0.3. So what is the conclusion that we can make here? So actually for the iteration formula, right, there are a lot of theory behind, just that there are a few factors that will determine whether you can get the roots or not. There are a few factors. The first one is, of course, the iteration formula might be a factor because different iteration formula, right? Some iteration formula totally cannot give you the answer one. All right, so you have to choose the correct iteration formula. That's the first one. Then the second one is you have to make sure that you choose the correct initial value. Alright, so if you choose the wrong initial value, you end up you also won't get the roots that you want to get. Okay, so there are two factors here. So that's why in the exam style question, for most of the time, they will straight away give you the iteration formula that they want you to use. Okay, because they don't want you to take the risk to find out the iteration formula yourself, but end up the iteration formula cannot use one. That's the first thing. And the second thing is the initial value. So for the initial value, they will always ask you to refer to the values that they give you in the sign change method. Alright, so it actually gives you a hint that, okay, you can only use the value from here to get an answer. If you want to use some other value outside, you might also still can get the answer, but there's a possibility that you won't get the correct answer. Okay, so the purpose that we are having the example 7 here is to show you, alright, two factors that affect whether you can get the approximate root that we want to get or not. So the first one is the iteration formula, and the second one is the initial value. Alright, so in the next video, we are going to discuss more, okay, examples and more questions from the past year, and to see what is the correct iteration formula that we should use to get the answer that we want. Okay, but of course, all the details, all the theories will not be asked in the exam. Okay, we just learn how to apply. Alright, so before I end this video, usually there are a lot of students who will ask one, like they will ask me whether when we write all the iteration here, if let's say your answer is a bit different from mine, is it okay or not? Alright, so if let's say your iteration formula, the iteration values here that I highlight here, all this, okay? If let's say you realize that maybe the last number or the last two digits are not the same as mine, it doesn't matter actually. Okay, as long as the final answer, the root that you can get is the same with mine one, then it will be okay. Alright, okay, so I think I'll stop here for this video. Then next video only we discuss further about some other examples.